Welcome to one of the last panels of this conference. I hope you guys all had a great one. I was particularly excited to be asked to moderate this panel because artificial intelligence, to apply that to some of the ills of our society, lending bias, I thought would be something really interesting to explore. So first of all, before we start, I'll have our panelists introduce themselves. Olga?
I'm Olga Harris. I'm a director with PwC Model Risk Management Group. I've been with the firm for about 10 years now, and I specialize in model development, model validation, and model risk. My primary area of focus have been consumer lending, so credit cards, mortgages, auto loans, and over the past couple of years, there have been an increased interest in its usage of machine learning models, especially they first started in marketing and fraud detection, and now they're rapidly moving in the underwriting. And obviously, in the underwriting space, they potentially can have more impact on how the society as a whole treats fairness, right? So I think from that perspective, it's interesting how the firms react to this, how the model developers react to this, and how the overall risk associated with the usage of this model is being mitigated. And I love to be here, and it's nice that I get to share the perspective.
Thanks. Hi, I'm Seth Silverstein. I'm the Chief Credit Analytics Officer at Zest AI. I've been at Zest a little over 3 months. Previously, I was at Ally Financial, where I was the Chief Modeling and Analytics Officer. And before that, 20 years at Bear Stearns, running analytics and fixed income. This panel is extremely exciting to us at Zest because we really looked at fairness as it comes to AI, because one of the issues that happens when you have many, many variables going into these models is that it's much harder to detect where fairness can creep in. Usually it's not intended bias. A lot of times it's the impact of the bias that comes in afterwards. So it's very important to be able to look at all the variables, their interactions together, and figure out whether there's actual bias going on. So thank you for having me, and excited to be here.
So before we get started and delve too much further in, let's define what exactly bias is and what are some of the problems that occur when biases exist in lending.
I think overall, right, when we talk about bias, as an economist and a statistician, I think about it, first of all, as just general model bias. And in the industry, general model bias is defined as the ability of the model to predict an outcome with a certain degree of accuracy. So typically, if we see a model that persistently over or under predicts, this is what is referred to as bias in the general lending industry. If your model is designed to produce the likelihood of a customer default within a 24-month window, a model that produces a 5% default rate, and then your actual default rate in the population is 10%, it can potentially be suffering from a bias, right? You're potentially under-predicting. If we think about fair lending context, or in the context of this discussion, right, bias can be something more than just the ability of the model to predict accurately, right? It's the ability of the model to predict outcomes that are consistent between different demographic groups within your population. So if we think about, I was thinking about hypothetical example, right? If we sort of talk about bias and fairness, and something that I came up with is, for example, you have a model that produces, like you're trying to predict the likelihood of a credit card default within a 24-month period. Then you have two groups. You have college students, and then you have senior citizens. So it could be that your model is producing the likelihood that college students are likely to default about 10% of the times, and then senior citizens are likely to default 5% of the times. Does it mean that your model is necessarily biased? It depends, right? It depends on what are the credit characteristics of your groups. So it's just important to compare people who are similarly situated, right? If we think about the terms used in the fair lending industry, right? Similarly situated means that generally their credit risk characteristics are aligned and the product definitions are aligned. So I think when they think about bias, in that context, right, that's sort of, it becomes a little bit more complex, and that's when we go into the area of thinking like what fairness is, what is our specific definition of a bias, and I think there's still sort of no consensus in the industry of what it is, but at the same time, there's regulatory expectations, right, and we know that. The regulators come in and they have their own methodologies and their own approaches, and I think they're sort of pretty specific in terms of what they define as bias.
Well, the one thing I'll say is that there's a great quote out there that some of you may know, that all models are wrong, some are useful. George Box, one of the great statisticians of the 20th century. And what it really means is that you really have to validate and verify all the models that you have, because bias creeps in everywhere. And again, as Olga said, there's different meanings of the word bias. One of them that I think is important, it happens when models overfit. And what that generally means is that you're trying to fit a curve through a bunch of data, and you may not necessarily get it perfectly right if you don't have enough either data to work from or data attributes that you're working with. So some of those attributes may predict something that may happen, and it's right according to historical data, but going forward, you may not have all the variables that were needed to create the model in the first place to make a better model. So we should always be worried that we don't have enough data, whether it's historical data of outcomes that happen or input data, to make sure that your model is going to be fair and not biased. And on the other side of it, I think it's extremely important in terms of fairness, because one of the things that I did as a modeler at Ally for a long period of time is we had to go to our compliance group and show the variables we were using in the models, and I'm sure you've done that over the time too. And sometimes interactions of variables are extremely important when we're looking at models, and this is where machine learning really comes into play, because your standard logistic and linear models look at one variable at a time. I always use the example of a standard model is y equals 5 times x plus 3 times z, or however we make it up. And the two variables that you're using there have to be uncorrelated, or else the model really doesn't work very well. Any correlation between the two variables, your model gets biased in a way. So let's say, for example, we can choose two variables, one being personal income, which seems like a really good variable to use for a credit model, and the other being state, for what reason we've found some variables there. If you look at the two variables separately, say, well, personal income, there really isn't any chance that it'll be biased in there. Maybe historical results have shown that certain groups have less or more income over time, but you really need that variable to form the credit model. And then state, it's very wide variety of people in each state, not a problem. The problem is when you put the two together, and now you have income and state, all of a sudden you can create biases where maybe, for example, in Nevada or Arizona, you'll have a certain group that comes out because of the two variables interaction, where it would be different in New Hampshire. So we really have to look at modeling very carefully when we're trying to figure out the biases that may come in.
So last year, AI and lending bias really grabbed the headline when a tech entrepreneur said that when he and his wife tried to get an Apple Card, he got 20 times the credit limit. And then the co-founder of Apple, Steve Wozniak, said it occurred to his family as well, that he got 10 times. And that really left sort of a bad, grabbed headlines and a lot of questions about Apple, Goldman Sachs, which was the bank backing that card, and also about AI. So I know neither of you were involved in this situation, but could you perhaps diagnose what might have gone wrong? What did they do that was inappropriate, or a mistake that they made? And what are some of the things that you can mitigate against it?
Okay, I'll take this one first. So like was said, I wasn't personally involved, but in thinking about it, because at Zest we always try to figure out how we can make models better. One thing that might have happened is because of the larger and larger use of automated underwriting, and people, especially credit providers, are trying to get more and more automated underwriting done. And in these cards case, if you go onto your phone, you can type in your social security number, hit glow, and 2 seconds later it gives you a credit card. Literally, you have your credit card on your phone. So what happens here is that the more and more automated underwriting, we have to use more and more data to create better models, but we have to be very careful about the data we're using. And a possibility in this case was that they were using personal income. So, for example, if you were a family, wife, husband, child, however it is, the man or the woman may make the income in the family, and the wife may be a stay-at-home mom or make less income, depending on the case. So if you only use one Social Security number and one personal income variable from it, and you're doing automated underwriting, which has to get the thing done very quickly, you may have problems because you're not getting all the information needed to create a full picture. For example, maybe you might have used joint bank accounts in the case where you get the husband and wife Social Security number, or family income in that case where it equals out. But when we're doing things where you're only using one Social Security number, and we only have certain data information and we're not checking other variables that may be useful, outcomes can be coming out like this. And the problem is that this is going to happen more and more, and we have to be more and more careful about how we're creating models, because, again, historical performance doesn't create future, as they always say in investing. And you have to look at to make sure that your model is not overfitting in a case where you're getting bad results or unfair results just because you tried to create a better model.
And I think to add to that, right, typically an underwriting shop or a bank would have their fair lending compliance program that after the people who developed the model, right, they tested it, to Zeth's point, right, it needs to be evaluated in terms of how it's fitting the population. It also has to go through compliance reviews. And typically those situations are being caught on the back end, right? So a robust compliance program will help you evaluate whether or not you're coming out with different outcomes for similarly situated borrowers. And in that situation, I think it could have been a similar situation where we think, oh, income, personal income is a variable that is predictive. The personal income variable is the variable that's okay to use. And after we're controlling for similarly situated borrowers, right, we're controlling for personal income. And then after controlling for personal income, everything comes out to be looking fine. But if you think about, is personal income the variable that you want to have in there? How is personal income measured? So a little bit more thoughtful approach to the compliance program or to the fair lending testing would have helped in this case.
So Senator Warren, who's no longer the leading Democratic candidate for the nomination for presidency, but still a very powerful senator in the financial services world, said women might have been discriminated against by an unknown algorithm, right? So what is the regulatory consequence, maybe the political consequence of not being able to address this and having other headlines like this? You mentioned fairness. What are some of the consequences of not getting this right?
I think it's more of a policy question, really. I think, as we're trying to sort of build trust in the society and bridge some of the political divides in this country, I think fairness is a very powerful concept. And I would leave it at that.
Well, I'll go a little further. I think the term black box is a dangerous term because I think people start relating black box to AI and machine learning. And they don't necessarily have to be black boxes. The key is explainability, right? If you don't have the ability to create correct adverse actions from your results, you're going to create models that aren't compliant, aren't really truly regulated the way they should be, and it's a consequence. So a lot of firms have been playing with AI right now, and as was mentioned earlier, they're using it in spaces that are not really regulated so they can get away with their black box. But once you get into a very regulated area, like credit decisioning especially, you have to have models that are truly explainable. And some of the algorithms out there, over the last year or so, more and more explainability techniques are coming through, like SHAP in terms of machine learning, but there's a lot of assumptions that have to be made in terms of those explainability algorithms, and they can get wrong depending on how things work. So we really want to get a very truly explainable model, and once you have that, then what you do is you work with the different regulators, compliance teams out there to make sure they understand it as well. We've been working with the government for many years, having them understand our explainability methodologies. We have a new, away from the black box, we have actually a paper out there that's going through the Journal of Machine Learning that looks at our explainability techniques, which is generalized integrated gradients. And the Fed, the CFPB have been very favorable looking at that kind of explainability and saying this works. So I think that's the key, is to really have an explainable model.
And so I think maybe, yeah, just maybe on the topic of explainability, I think it makes a lot of sense, right, in terms of adverse action codes, right? If you think about how machine learning models are typically constructed, and what we see in machine learning models is a lot of nonlinearities, right? We see that, for example, the expectation is as your credit score is increasing, your likelihood of being denied a loan is decreasing, right? But if you have a machine learning models that takes a lot of different attributes and combines them in nonlinear ways, you can be coming out with a model that doesn't really give you that linearity, right? And if a customer is trying to understand what it is that they need to do to improve the likelihood of getting a credit card, right, they have to be able to really zero in on the decision code, right, and see like what actions can be taken. So I think in terms of designing machine learning models, the idea of that there should be some degrees of linearity, right? And in the regulated space, as Seth mentioned, we cannot really take human out of the loop if we think about designing effective machine learning models, because some adjustments would potentially need to be made, right? You have to be able to explain and rationalize the results, and be able to support them and make sure your consumers can trust you, right? And that you don't lose consumers because your machine learning model produces outcomes similar to what we see.
So I do want to move on to the positive effect of AI and what it can do to mitigate. But before we go there, I do think there is like a 800-pound gorilla that you sort of alluded to, which is how do you build trust and some of the different parameters. So before your credit card score, you might think, okay, how often do I pay my credit card on time? But now with AI learning, you can have also things like, do I eat at restaurants more, or do I buy groceries more? All these factors that seem very invasive to our privacy. Privacy is a big factor when we're looking at big data and AI. So how do you get people to trust their privacy, trust this mechanism when there's such concerns about privacy?
Sure. I think the gorilla in the room is what we now call alternative data. Mm-hmm. And alternative data could be anything that's not standard financial information. It goes everywhere from who you look at, who your friends are on Facebook, or what restaurants, as you said, you go out to. It doesn't have to be that, though. And I think that it's going to be a long way, if ever, before regulators, compliance groups will allow that kind of data to get into models. I think there's so many issues, especially with explainability, just because there is a predictability between one occurrence and another doesn't necessarily mean that it's a very good predictor going forward. So I think that's, the key is to use the correct kind of alternative data. And there's certain data out there that's very important that is still financial information. For example, how you paid your rent over time, your utility bills. There is data that we've used for payday lending, student loan information. All these are fairly, common financial information that can be gotten without too much risk. And then the other side of it is there's trending data, which is becoming more and more important over time. And as I always say, 680 FICO is not a 680 FICO. It depends on where you were the month before, the month before that, the month before that. If you were getting better in credit, and you're a 680, or you're going down because you lost your job, it matters. So trending data is really important. as well. One of the problems with using all this kind of data in a standard logistic or linear regression is, as Olga pointed out, is that if you have these variables that are correlated for any reason with other data you're using, generally you can't use them in a model because, again, the variables that you use have to be strictly uncorrelated, or else the interactions between the two of them will cause issues. Sometimes when you're building machine learning models, the interactions are extremely important. And that's where we can actually take these new kinds of variables and add to the standard variables that we had before and create better models, because now the nonlinearity matters, and it's important instead of not being important. The other side of it is also, when you're using machine learning models, is you can actually not have the standard relationship of, if one variable goes up, that means your score has to go up as well. When you have two variables that are interacting with each other, now what you can have is a variable, depending on if it's low or high, can mean something different totally towards the score. A good example of that is in fraud modeling, whereby if you have a lot of accounts with no utilization, that generally means that's a good thing for a credit score. But when you're looking at fraud scores, if you're applying for credit and you have many accounts with no utilization, that could be a fraud interaction. So you want to be able to pick all these things apart, because the new thing nowadays is synthetic fraud. And synthetic fraud is very difficult to detect. You don't really get it in the first couple months where you apply for credit and then you don't just pay your loan down. It can happen over years, where you're building up credit on many different accounts, and then all of a sudden you just don't pay. And I've seen statistics out there that say that probably 20 to 30% of actual defaults may be synthetic fraud. So it's something that we really have to look at and put into our credit models, and not necessarily in fraud detection models, because you may never know if it's a synthetic fraud event or an actual credit event.
And just to add to that, I think in terms of the alternative data use, right, we know that the Consumer Financial Protection Bureau came out with guidance on alternative data usage just recently, and they said, it can be useful, but exercise caution. And it's interesting that an example that they give for alternative data was really your vanilla type of alternative data, right? That was income, basically your cash flows, right? Your bank account information. So they were not talking about the restaurants, they were not talking about your iPhone usage, they were talking about something that cannot be necessarily found in your credit file, but it's strongly correlated with your ability to pay your credit card or your debt going forward. So I think the idea is that we're very far away from using the true forms of alternative data, but if we think about the usage of alternative data overall in underwriting models, we have to be careful in terms of introducing bias, right? If we think about, for example, my example of the college students versus senior citizens, right? Even if we don't have the identifiers in our data, for example, we're trying to build a model with alternative data, and we find that people with more than 30 apps on their phones are more likely to default on their credit cards going forward, right? And somehow it happens to be that college students are the ones who have so many apps, tons of apps on their phones, so we end up introducing a variable into our model that can be directly linked to the attributes that should not be relevant to your underwriting characteristics, such as your demographics. So this is one of the sort of dangers of introducing alternative data that is not necessarily related to your ability to pay credit card debt or any other type of debt.
So what can AI do to mitigate some of these societal ills that really pains people on a human level, communities, and that society in the whole? So let's tackle racial bias. So what could AI do to help against racial bias in lending?
So I think in terms of AI and bias, right, if we think about what we talked about before, right, I mean, it's a loaded question, right?
Yes.
Because as bankers and people who are involved in finance, right, we're trying to basically maximize a couple of objective functions at the same time, right? We want to make sure our models are producing accurate results, right? We want to make sure that in terms of being able to accurately predict the defaults, our model gives us a good degree of accuracy. At the same time, knowing that in the society in the past, there were some issues of inequality, right? Unequal access to credit, things like that that affected different demographic groups disproportionately. We want to, at the same time, try to impose a restriction on our model that would potentially help disadvantaged borrowers to get better access to credit, to be able to exercise, their rights to be a consumer equally with any other groups. So from that perspective, right, it's important to design our models that optimize those two objective functions simultaneously. And the idea is that, there's always bias in human decision-making. The bias in human decision-making ends up being the model, the bias in the models, because oftentimes AI models are designed to mimic human decision-making. So we have that concern. Then we have a concern that the data that we're building our models on may not be equally representative of different demographic characteristics or different demographic categories. And for example, if we think about ethnic or racial minorities having less access to credit in the past, our data would underrepresent or undersample those minorities, and we will not be able to design a model effectively without some degree of human intervention. For example, we can employ some resampling techniques to make sure we try to make our historical data more representative of what we think the society should look like and the equal access to credit should look like. So I think there are different ways to mitigate bias or make sure that AI can mitigate bias, but it requires really thoughtful approach, and it should go back to thinking about the data that you're using, thinking about the algorithms that you're using, and thinking about what it is that you're trying to maximize and what it is that your objective function is.
I think we also have to look at, when we talk about bias, there's, especially when it comes to the CFPB and other regulators, there's two really different terms, one being disparate treatment, which really means that you're actually looking at somebody and you are deciding on a loan based on the way they look or what origin they're from. The other is disparate impact, which is a much more general term, which means basically your model in its totality shows that there's bias in there. Much harder to detect because many variables going into the algorithm, and you don't necessarily know what's happening. So generally what we do when a regulator or compliance department comes to us and says, it looks like you have disparate impact in your model, you go to each variable that you used in the model, and standard logistic regression models may be 30 to 50 variables or less, and you have to go through each variable and decide, is this variable, all things else considered, a variable that causes bias, right? An easy one would be, okay, ethnic origin, right? You can't use that in a model. But there are other variables that predict that just as well. So what we've done at Zest is we actually have created adversarial models that go on top of our machine learning models. So our machine learning models will be built to predict a certain outcome, a credit default, over a certain period of time. The adversarial model will sit on top of that model, and because we have a lot of computer power in machine learning, you have the ability to say, okay, how well does that model that's predicting credit defaults now predict inequalities, whether it would be racial bias or bias men versus women, et cetera. And what we can actually do is create an efficient frontier of different models underneath that basically predict the same amount or are as accurate as they were before in predicting credit defaults, but use slightly different variables that are less biased when it comes down to it. As Olga said before, a lot of the historical variables that were used in finance are inherently biased. If you go look at a standard credit score that you can go out on the street and get, and you run it through our adversarial model, it shows that that credit score is biased. It's racially biased. If you use less of that information, but more variables, especially newer kinds of variables in terms of alternative data, things equal themselves out, because now we're almost on a level playing field where if somebody all of a sudden now pays their monthly rent on time or their phone bill on time over the last 12 months, you're not going to get that historical bias anymore because everybody now has a cell phone, everybody pays their rent, et cetera, et cetera. So we can use these variables in an adversarial model and predict a better result and have less bias.
I think whenever there is a good product, that might be a societal good, it doesn't really catch on unless there's some also perhaps an economic value as well. One of the interesting things about this conference was the dominance of ESG. And that has become sort of an inflection point in US fixed income and securitization, and a sort of a movement of people actually putting cash where their concerns are. In what way do you think AI might be able to help firms or businesses that want to sort of operate in this ESG environment? Do you think there's a role?
Well, I think that AI and ML firms in general, there's what's the right way to say it is, a lot of people say they're in AI and ML and they're not really there. A lot of times what they'll do is they'll use AI to predict certain variables and then put it into a logistic regression model and get a certain result. I think that if you really truly use ML the way it was supposed to be used and explainable, I think it helps in these efforts, and I think it's going to really make models better, which in the end of the day makes everything better.
And I think overall, to echo the sentiment, right? I think right now a lot of people are talking about machine learning models. It's like big data a few years back, right? Everybody was talking about big data. Very few people knew what it meant and what it actually, like what the usages are. So now we have machine learning models. So there's a lot of hype around it. I think at the same time, the machine learning models are really making big strides. So I think the future is bright, but in terms of being able to develop the models that actually work, that are predictive, and they are performing better than our standard models, I think there's still a little bit of way to go from that perspective.
And that was my next question. What does the next step need to be? What for AI to really be effective and to catch on the way, the potential, to actually play out with the potential that it has? What's the next step?
So yeah, maybe. I think part of the challenges with using machine learning models now, when I think about machine learning models, right, we can think about dynamic and static models, right? So dynamic models is the models that continuously recalibrates itself, so that continues learning, and static models are the models that use the machine learning techniques. You estimate the model, then you have the coefficients, you apply those coefficients in your underwriting framework. So this is your static model. So if we think about dynamic models, I think very few firms in the industry right now are using dynamic models, just because they're very hard to implement, they're very hard to monitor. The controls around using dynamic models control frameworks haven't been well established. But I think this is the future, right? Dynamic model, this is how they're different from the static models. The idea is that they're going to continue improving, they're going to continue learning, they're going to give us more accurate and better outcomes. At the same time, I think one of the challenges that the practitioners experience is around data governance. So if you think about a big underwriting shop or a big bank, and you think about machine learning models that relies on 300 variables, right? You have to be able to establish controls around your data. You have to establish data lineage. You have to understand where your variables are coming from. They have to be cleaned and maintained going forward in a consistent fashion. So I think part of the way to make machine learning to help machine learning models take off a little bit more is to think through the data governance requirements and improve your data governance framework.
Touching a little on the dynamic versus static, I think that it's going to be very hard in the next couple of years to have any dynamic models being going through regulators and compliance groups. I think it's just, there's too many things happening, and when the model changes, you don't know what is now causing it, the new effect, and it's very hard to regulate, it's very hard to explain, and sometimes you get a lot of bias created just because it's learning, but it's not learning the right thing. So I think it's pretty scary. I think that if you're building static models using machine learning, it's a lot easier to explain and build an algorithm and auto documentation, which I think is extremely important, of how the model built itself. The thing I think that's going to really cause an explosion in machine learning, and it's coming now because if you look at every paper or document material out there, everybody's talking about alternative data. And to really get the full power of alternative data, you really have to use machine learning techniques, because you can't just fit that, as Olga said earlier, into a standard linear model. The thing that's going to really happen, is a term that I've used in the past, but most people know, is adverse selection. And what happens there is certain groups or credit people will build better models using machine learning or alternative data or both, and all of a sudden they have a better view of the customer than others that have older models that aren't very good. And all of a sudden, these firms are going to get adversely selected, which means that the customer is going to go to the person who has the better model, and the person who doesn't, or the group that doesn't, is going to have the worst customers, even though they don't know it. And over time, what's going to happen is that they'll figure out that something's happening in other models, and it always happens, and it happens quickly. When I was at Ally, for example, people knew exactly when we put on a new model because things just change. And others see that they're not getting the loans they used to get, and they're getting other loans that don't look as good. And the market has to catch up very quickly. So as soon as some large firms put on these machine learning models with a large amount of data going into them, I think people are going to have to catch up very quickly, and it's going to take off. That's my projections anyway.
For it to take off, what time frame are we thinking? I know this is prognosticating and looking into a crystal ball, but what environment and what time frame do you think this could really take off?
I mean, yeah, I feel that, it's advancing very fast, right? We have the neural network models, which I think is probably the future. They're more complex, and with the tools that we currently have, for example, Python, right? It has lots of different pre-coded machine learning routines. There are people who are just sitting at home bored developing, no new machine learning algorithms. So I think given the sort of resource sharing environment, given that a lot of people are interested in the topic, I think in terms of how the industry is developing, it's going to be very rapid. In terms of how the practitioners are adopting those models, I think it's going to take time because, again, we cannot take humans completely out of the loop, especially in the areas of underwriting, like fraud detection and marketing. I think practitioners should exercise caution, right? We have to be able to explain things. There's still regulatory environment that we have to be concerned about. So I think there's like two factors that are sort of working against each other, but I think the regulators and the practitioners will have to catch up.
Well, I'm a little more optimistic just because I think that we at Zest have some fairly large, well-known companies using our models right now that have gone through the regulators and their compliance departments and are online. So the results haven't come through yet. But I think that over the next year especially, I think there's going to be a large takeoff in terms of machine learning, and I think people have to be aware it's happening.
Yeah. And I think most of the large credit card issuers are now developing their own machine learning tools. So in terms of PwC's exposure, like we're talking to our clients, and most of the large credit card issuers are now actually using something that has a machine learning component in the underwriting systems. And yeah, to your point, I think we're getting there.
So I want to open up to questions, if you got the audience, if you have any. Otherwise, I'm going to hog up all the questions myself. Is there any questions? Well, in that case, I'm going to still.
Long 3 days.
Yes, it's been a very long 3 days, and so right before your flights, or maybe going back to the blackjack table. So you mentioned like how humans are going to interact with this machine learning and with AI. Could you just give some concrete examples of how people's day-to-day lives, jobs will change? Because there's still, as you said, humans necessary to oversee and interact. What's the future going to sort of look like for the people who are engaged in this sector?
So I think we have things like robotic process automation, right? So this is not necessarily machine learning per se, but these algorithms that people can use to automate routine tasks. For example, if somebody has to populate the spreadsheet repeatedly over and over, right? Now we can configure. It can take a person a day to configure a robotic process automation algorithm to do it, and that can be done very fast. And somebody whose full-time job was to do that, they can find themselves out of a job, basically. But the idea is that, from that perspective, it's a new industrial revolution, right, potentially. So hopefully, the impact is going to be mitigated by the fact that people can get upskilled, right? They can move into into the areas that require more subject matter expertise versus routine tasks. So the idea is robotic process automation is there to improve people's lives. It's not necessarily there to make people out of jobs, but in the reality, I think there's going to be an impact on both sides, right? So it's going to make people's jobs less monotonous, but at the same time, people have to be ready, and then they have to be thinking about upskilling and what it is that they need to do to create value within the organization.
Well, getting more into credit, I think that machine learning and alternative data are going to create more auto decisioning. And what that means to me is the fact that firms are going to now be able to turn down applications that sometimes went to a human underwriter that really should never have gone there, and some applications are going to be accepted that have wasted the time of human underwriters as well. So what that means is the box that a human underwriter is looking at is going to be much smaller, but they're going to be able to look at them much more carefully. I think most of them, if you talk to them, are overburdened. They have to look at applications within a certain amount of time, and they're judged that way. And they don't really have the time to really look at applications as carefully as they should on the ones that are on the fringe either way. So I think with more automated underwriting, because of machine learning, I think these underwriters are going to be able to really spend more time on applications and make a much more educated decision instead of just glossing over and turning down an application that may or may not be a good application.
So for my final question, what do you find the most exciting about what you're doing in AI? It is technology, it is progress. What do you enjoy about it, and what do you find exciting? What do you want, like, last takeaway to the audience?
To me, again, I've been at Zest for 3 months, and it's been the most fun I've ever had in a job. And the reason is because it's really, my lifetime is, in terms of employment, has always been in the modeling area, but I felt like I came to a wall, especially in the standard modeling techniques. We, in my last job, got all kinds of new data in, trending data as well as a lot of alternative data, and we built a model, and we can only use 2 variables out of it based on the general techniques that we're using. And I met up with Zest AI, and all of a sudden we're building models that have so many more variables and are so much more predictive. And that really is exciting to me, because I think we're coming on a new world of building better models and getting more people that deserve credit.
I personally like trying to break things, like in terms of my interaction with AI models, right? I try to poke holes and see, what it is that is not working as expected, how we can make it work better. I think in terms of specifically underwriting models, right, the issues such as nonlinearity, adverse decision codes, things like that, just being a geek, I think I find those exciting. So trying to improve explainability, trying to improve predictive outcomes, I think this is the things that I find the most fun.
Great. Well, it's been fun for me moderating the both of you. Thank you so much. And thank you for staying with us. I know it's the third day of a conference. I think it's the fourth day, third day. So thank you so much.